Hey guys, what's up? Okay, first of all, let me tell you, I'm also a student and I don't have any personal interest in making all these videos because I can just say I'm having fun, just to have some little fun. Trying to make videos like these. So let's get started with chemistry today. All we're gonna learn about the basics of alkanes and cycloalkanes, and this is going to be a very fun journey, and I hope you stay until the very end with me throughout the journey. And let's get started. So first of all, what are alkanes? You might be aware of alkanes, but it's my duty to tell you from very scratch. So let me tell you what alkanes are. Alkanes are single bonded, single bonded saturated carbon compounds with hydrogen to the side. That's why they're also sometimes referred to as saturated hydrocarbons. So first of all, let's discuss alkanes. I know I have a very terrible handwriting, but suffer with me with this handwriting. But the better you learn is the most important thing I could guess right now. Okay, so alkanes are, as I said, single bonded hydrocarbons. Okay, so alkanes are single bonded hydrocarbons. Okay, well, we get it. Now, for the nomenclature, you need to put an aim at the end, and they have a general formula. So let me tell you one thing, that I'm not going to do all the thing alone by my side. I'll be referring the book as well. So just bear with me with this thing, because I'm also revising. I'm also a student, as I told you in the beginning. So it is CnH2n plus 2. This is the general formula for alkanes. Wow, you got it. Alright, let's just move ahead with some of the structures of alkanes and look how you could give the IUPAC name to them. Okay, let's get started. For example, let's give you an example of features of propane. This one is a 3-carbon and hydrogen alkane. No, they're not 3 hydrogens. There might be 2 and plus 2 hydrogens in it. So if it is 3 carbons, then there might be 2 place 2 in place of n plus 2. You will get C3H8. So this 8 are the number of hydrogens you're going to have in the whole structure of propane. Okay, so it would probably looks like CH3 CH. How many carbons you need? 3. You need how many hydrogens? 3. And you can have 2 here, 3 by there. Now, let me tell you one more thing. This word help you that this CH3 group is called alkyl group. This is a formula CnH2n plus 1. CnH2n plus 1. This is a formula for alkyl group, which is CH3. It could be look like C2H5 too. Or maybe in propane case of propane, this would be known as ethyl. This is methyl. And in the case of propane, it would be C3H7, which would be known as propyl. Okay, let me tell you one more thing. If I could make the structure like this, CH3, CH3, and put this, okay, wait, CH3, put this CH3 down instead of in a row. If I put it down, it would have been known as isopropyl. No, I'm not going deep into the IPEC name because this is not today's topic. Today's topic is to talk all about alkanes. So I'm going through all the topics little bit by little bit. And in no time you're going to learn everything about alkanes. And you'd love to know about some knowledge about the cycloalkanes too. Okay, so if I have to put this structure so in arrow form, what would I do to put, the arrow forms? So I would really look like this. What if this type of structure? You can see there is only a single bond in this, so that means this is an alkane. So how would you name this type of alkane? See, you have a down group. This means this is the iso type of isotype of compound or hydrocarbon. So you have, let it be, it is CH3. If it is CH3, this must be CH2. And if this is in all the ends, let me tell you, in this case, all the ends are carbon. So we have the longest chain as this. So this is also CH2, and this might be CH3 once again. So how many carbons do you have? You can see there are 4 carbons, so it is bute. So this is an alkane we call butane. But check the hydrogens first, careful, before writing ane as a suffix. So before writing suffix, you need to calculate the number of carbons. So 3, 4, 5, 6, 7, 8, 9, 10. Which is appropriate. You can call isobutane. Isobutane. Sometimes it's referred to as isobutyl group. Okay, so let's just move ahead with some more details about the alkanes. Okay, so let's first talk about the preparations of alkanes. Yes, so we're going to talk about the preparations of alkanes. So I'm going to give you a glance of my book right now because I don't like to write all the things because it is just not just a waste of paper but also energy, and it saves time if you can read it on book. And if it's necessary, I will write it on the notebook. Don't worry about it. I'm not going to do everything from the book. Okay, so preparation of alkanes. So first of all, you can go through the reduction of alkyl halides type. Reduction of alkyl halides. Let me write it here. Preparation of alkanes. Now you can prepare alkanes through numerous chemical reactions, but there are a few which are very important that you should do mostly, and they're important. You should not leave them at all at any case. Let's just go with the first one, which is reduction of alkyl halides. Reduction of alkyl halides. You all know that reduction is nothing but addition of hydrogen. It is nothing but addition of hydrogen. Is that so? If this is so, then we could write as, let me tell you, alkyl halides are usually written as Rx, where R stands for alkyl group and X stands for any halogen. So we call it alkyl halide plus hydrogen, 2H to balance the equation. We have got from this RH plus HX. let's go through an example. If it is CH3 is alkyl and the halide I'm taking Cl plus 2H, we've got CH3 or CH4. I was going to write CH3H, which is nothing but CH4 indeed, plus HX, which is HCl. Got it. And of course, for the mechanism of this, of course, radicals took part. Not carbanions, carbocation, cations, or carbenes, nitrates. None of them took part. Just the radicals took part. Okay, so let's just go ahead with using some more reactions to prepare the carbon with hydrogen compound known as alkanes. Okay, so this time we're going to follow Grignard reagent. Now, Grignard reagent is a magnesium reagent which is formed typically from the name of Victor Grignard, a French chemist who won the Nobel Prize in Chemistry in 1912 and prepared Grignard reagent. He did nothing but heat dry magnesium, turning with alkyl halide in the presence of dry alcohol-free ether. So it is just like magnesium with something like, I would say it's like he just added Rx, which is nothing but alkyl halide, plus magnesium. It would form RMgX, and this RMgX is nothing but our Grignard reagent. Now you're going to see how this Grignard reagent turns into an alkane. So I would call R as CH3 right now, and for Mg we have Mg, and for X I'm going to use Br. So CH3 Mg Br, and let's just add, for alkanes we have to add any more compound like phenols, phenols, water, or ROH compounds, acids. You can add anything to produce alkane. So I'm gonna add H2O. So what you're gonna see here, you're going to have CH4 plus MgOH spear. Yes. Or you can write this one as CH4 plus MgOH Br. I think this will look more cool than the other one. Okay, so this is how you can prepare alkanes from Grignard reagent. Let's move ahead. Now this time we're going to understand how we can produce or generate alkanes through some more reactions. Like, for example, this time we're going to follow up this with what's reaction? I think this one's the most famous reaction for preparing alkanes. So why don't you try it today? So what's reaction? How will this go through? So what's reaction is nothing but we have our X group, which is alkyl halide, plus 2 sodium, and plus, since we've taken 2 sodium, we have to take 2 of this alkyl halide. How would we take? First of all, we're taking it like this. Next one, we'll write it something like this. Now, it's like a game. You can have C. From this X to this X, you have to turn everything. You're going to have like R group plus 2NaX. See, what is it? This is the first reaction. Let's go ahead with an example to understand it more battlely. Let's take CH3 instead of R, and for X, I'm gonna have chlorine plus 2 sodium plus again chlorine and CH3 group. Take Cl to seal everything. X to X. Look what you've got. C2 at 6 plus 2 NaCl. Look, you've got alkanes. This one we call ethene. Sorry, ethane. I'm mistaken. I misspoke it right now. I'm really very sorry for this. For misconvenience. Okay, so C2H6. This is nothing but ethane. We got an alkane. So this one's called Wurtz reaction. And this barely consists of a mechanism by free radicals, where free radicals take part and they change their positions, and that's how the reaction takes place. And you don't need to go through in very details because I think this is out of the context for today. Okay, there is another reaction called fitting reaction, which is same as that of Wurtz fitting reaction, but it has no significance for preparing alkanes. This is what people think. Do you know what I think? This is like a alkane formation with an aromatic ring like benzene. So I think we should discuss this too today. Are we ready to discuss this one reaction as well? So let's discuss it. So I'm gonna write it here: fitting reaction. The before one was a Wurtz fitting reaction, and this one's a fitting reaction, which goes by same mechanism and same way. The one we're taking like Wurtz reaction. This is called fitting reaction. I have right now a compound, an aromatic ring. Let me call it benzene. I've made a benzene. Take Cl. Now I'm gonna take 2 sodium and another benzene ring with attached chlorine. Now let's take chlorine to chlorine everything. You're going to have an aromatic single bond, aromatic and a single bond with 2 aromatics. So plus 2 NaCl. This is a fitting reaction. Now you might be thinking, what is its significance? It is an aromatic. This might be a double bonded alkene. But let me tell you one thing here to you guys. Look at this one. What do you call this? Yeah, this is a single bond. So 2 benzene rings connected to each of them through a single bond. Yes, that's what I mean. Why it has a significance in alkanes. Okay, so we've done so far Wurtz reaction and fitting reaction. Now I think this is the time to talk about Wurtz fitting reaction. So we're going to talk about Wurtz fitting reaction, which is nothing but the combination of the full 2. Let's go ahead then. So Wurtz fitting reaction will go like, you've got a benzene ring as you got in fitting reaction, and you got a chlorine group in this. Now you think that should you take chlorine for every time? No, you can take any halogen, but except of fluorine, because fluorine reacts with hydrocarbons. It is a very vigorous and exothermic reaction. That's why chemists don't make fluorine to react. It is very scary. Indeed it is. And certainly right now we need to focus on the Wurtz fitting reaction, where we can take any halogen instead of fluorine in place of chlorine. Or if you love to take chlorine, go ahead with this, no problem. Okay, so chlorine plus 2Na. Now this time it's a Wurtz fitting reaction, which is just combination of Wurtz reaction and fitting reaction we've did so far. So we've taken chlorine with an aromatic ring called benzene. Okay, so this is from fitting reaction. 2Na is common in both. Now let's take what we need to take over from the fifth reaction. It's nothing but RX group called CH3Cl. All you need to do what? Let's write the CH3Cl in like this way. This will look more cool. Let's take Cl to Cl everything out. We're going to have a benzene ring with CH3 group plus 2 NaCl. Now you might be thinking why I'm talking about this reaction in the preparation of alkanes. Now look at this. This is a single bond which you just need in the formation of alkanes. So you've got alkanes. That's what we're talking about this. And you need to do the same reaction in benzene group. That sounds specular, but it helps you to enhance your practice power and boost your concepts more often if you do this. Okay, I admit it. It's right to do. Okay, so let's go ahead with some of the more beautiful reactions that takes place to prepare alkanes. So this time we're going ahead with another reaction called what? Guess what we're going to do is it's last but least reaction, which is called this electrolytic reaction. I'm gonna have this one from the book because I don't think so this is that important, so let's do it. Okay, I don't want to miss anything that you would fall later say, oh, this was important and I skipped the part. So here, like our 2RCOONA, where R is just CH3 alkyl group, and you've got CONA, and you've did electrolysis, you've got RR together, plus CO2 plus TNaOH plus H2. We know that H2 and CO2 are the gases which evolve during electrolytic reaction. If you haven't know, go ahead with electrolysis because this is really important to know about what electrolysis and what are the electrolytes. There are two types of electrolytes called weak electrolyte and strong electrolyte, and this one is a very weak electrolyte because it is made up of carbon. Okay, now so this sodium gets put away with one of the hydrogen and oxygen group, and you just got this two of this R. This whole CONA gets rearranged in the form of carbon dioxide, sodium hydroxide, and hydrogen gas. But you will just get 2R from this. See the 2 from this, you got 2 R's, and just put it together. You made it. You prepared alkanes very well. That's all you need to do to prepare alkanes. Okay, so there are some reactions associated with alkanes. So I want you to go ahead with this today because this will help you to enhance your reaction learning part, because as more you do your reactions, you fell in love with this. Okay, so what should you do in the next one? I think I should make another video for this, and I'll upload it just after this one. So don't worry, I'm gonna make it up in the next video, because if I do this in today's video, it'll be a bit longer. We sound cringy to sometimes people, and there are many type of people, So let's do this in another video. So thanks for watching. Hope you have enjoyed and loved the session. So see you in the next lecture. Till then, take care of yourself. Bye bye.